Hello everyone, let's look at some additional examples using the quotient property, and we're going to combine it with some of our other properties like the product of powers property and the negative exponent properties. Whew, this should be just so much fun. All right, let's dive right in and look at an example. Okay, so b to the second over all of that stuff. Lots of ways we could approach this. You might like to work on the numerator and then the denominator separately, or you might like to approach the negative exponents first. I might say, let's get rid of this b to the negative third. I don't like him. Let's get it out of here. So we'll send him packing his bags and moving upstairs so he can be positive. Doesn't everyone want to be positive? Oh, man, these jokes are so good. Thanks for sticking tuned through them. All right, so we'll copy down the rest of the denominator there. All right, so we've got numerator, denominator. I'm going to clean up each of them separately. In the numerator, we've got a b to the second and a b to the third. So put our fraction line here. That's really b to the fifth up there. Terrific. 2 plus 3 equals 5. That's our product of powers property. Whew, tongue twisters. All right, where did that 16 come from? 4 times 4. Those are our coefficients. We can multiply those together. We've got a to the fourth and an a, well, that is a 1 there. All right, so a to the fifth, b to the second. Terrific. Can we simplify anything else? Looking around, I see b twice. That tells me there's more work to be done. We got some quotient property to be done here. So there's b to the fifth over b to the second. So we can use our quotient property to subtract. There's going to be more on the top, so b to the third on the top, 16, a to the fifth. If you're looking at a problem and thinking, how do I know if I'm done? 3 things. Does each variable happen only once? Yep. Also, is there any negative exponents? Nope. And did you simplify the coefficients? Yes, we did. So that one is simplified. Let's go get a real nice fun one. Woo! Man, doesn't that just get you excited seeing all of that there and knowing that we're going to simplify it into something nice and simple and compact and get excited. All right, fraction bar. Let's start picking and choosing some stuff. Negative exponents. I'm finding them everywhere. They're going to get new homes. Yay, new homes. Not that kind of home. So don't forget this negative. I'm going to tack them out there in front. Let's start replacing some things as we go. That 10 there is from the 5 times the 2. I might go ahead and say I'm just going to take the rest of the numerator terms, z to the 7th, x to the 7th. I'm then going to say, look, there was 2 things that were negative exponents in the denominator. Let's bring them upstairs. They can hang out with us now and be positive. Y squared z to the 4th. Terrific. All right, so we took care of everything in the numerator and those 2. No, we didn't take care of everything in the numerator. We took care of a lot of things. All right, so let's take care of these coefficients here. We've got negative 56 down there. We'll copy down the rest of the terms that are staying in place. X to the 9th, y to the 10th. We don't need that z to the 0. It's 1. 1 times anything is just itself. So kind of vanishes, so to speak, but it is just a 1. All right, so we also have an x to the 4th here. So we'll copy him down, and then don't forget there were 2 terms up in the numerator that were negative exponents. They get to come downstairs and be positive. So we got x to the 6th and y to the 3rd now that they're in the denominator. Okay, whew, lots of fun things happening. It might be nice to go through and double check that you took care of everything as you went. So if we look at things and start marking them off, the 2 and the 5, that turns into our 10. There's our z to the 7th, I see it. X to the 7th, I see it. Y to the negative 2nd down there. Z to the negative 4th. Okay, those were all taken care of. Great. On the bottom, 7 and negative 8. Yep, that's a negative 56. X to the 9. Yep, we got rid of that. Y to the 10th. Z to the 0 was 1, so we did take care of that. Yep. We also got the x to the negative 6th, the y to the negative 3rd. Oops, and I skipped over x to the 4th. We took care of that too. We see that. We got everything. So we didn't miss anything. This should be equivalent to what we had up above. All right, that is good news. All right, we still have some more simplifying to do. So we can look at a number of things to do, and there's all kinds of orders. Let's just stick in the numerator for anything we can do. So there's z's, 2 things with the same base. We can combine them. Z to the 7th and z to the 4th makes z to the 11th. The others we'll just copy along for the ride. Don't forget this negative out front here. Bring down the negative 56. I see x's in 2 places, so that's x to the 3 places there is x's. Careful. I missed over the 1. X to the 9, 4, and 6, so that's x to the 19th there. Terrific, and y in 2 places, so y to the 13th. Okay, numerator is simplified, denominator is simplified, but there's some simplifying across the numerator denominator. With the 10 and the negative 56, think of that as just a fraction, 10/56. Can that be simplified as a fraction? Well, what goes into both 10 and a 56? 2. 2 goes into both. So we can divide the numerators 10 by 2, and we'll get 5. And the denominator is negative 56 divided by 2 is negative 28. And now that I'm doing that, I'm thinking, don't forget this negative out front. He's still there. Or she. All right, so z to the 11th, x to the... Well, look, there's some on top and bottom. There's more on the bottom, so it's really going to be x to the 12th on the bottom. And y, so there's some on top and bottom, so there's actually 11 more on the bottom. The last thing we should really do here is think that we've got these 2 negatives that are going to clean themselves up. They'll cancel out, and so our final answer, 5z to the 11th over 28x to the 12th, y to the 11th. Doesn't that look like just a pretty packaged answer? Hey, yeah, I think you like it too. All right, thanks for watching. Hopefully this example helped you with some of the most difficult examples of using our properties of exponents so far. Stay tuned for more videos and more properties of exponents. Thanks.